Hello and welcome everyone. Thank you so much for having us today. My name is Nathan Harvey and I'm here together with my colleague Dina Graves-Portman, and we're here to talk about measuring DevOps. Dina, I'll turn it over to you to introduce yourself.
Sure. I'm Dina, and my background is in data. I was a data analyst. I've done data engineering. I've done data consulting, machine learning. I'm very in love with data, and I'm very excited to help bring meaningful data insights into the DevOps world.
Awesome, thank you. And hello everyone, my name is Nathan Harvey. And I am a developer advocate here at Google Cloud. And I've spent the last decade or more helping organizations understand the practices and principles of DevOps and using technology to apply those practices and principles. I've done so in a number of different places, but right now I'm with Google Cloud. We're really happy to be here with you. So I want to talk a little bit about DevOps and how do you actually measure DevOps? And we can go back almost a decade ago where Mark Andreessen said, software is eating the world. As it turns out, software's appetite is pretty big. It's eaten up a lot of the world, and all of us find ourselves working in technology companies today. Whether or not we started off as a technology company when our companies were founded, we are definitely becoming or are already technology companies today. So just what is DevOps and how do we measure it? Well, DevOps is a way of working in which we apply communication and automation to achieve velocity and reliability. We do this to make our users happy. But it's interesting because DevOps, like what does that word even mean? We struggle with this a lot. I think that these are really foundational principles here. But when you see me talking about DevOps as communication and automation, velocity, reliability, happy users, maybe you also think of the word or the term SRE, site reliability engineering. Maybe you think of SAFe, the scaled agile framework. Maybe it's just modern technology. Really, language is important, but outcomes are more important than labels, especially labels which try to draw really crisp lines and have the potential to diminish collaboration. So as much as we like to try to define DevOps, I think it's really about how do we get to happy users. And in order to get to happy users, I like to revisit a little bit slightly more fundamental question. And that question is, why is the business? Why is our business in business? We're here to help our customers, so we need to start by understanding who they are and what value they get from the business. If we don't understand who our customers are, if we don't understand the business of our business, it's very hard for us to be successful and even harder for us to collaborate across different departments within our business. But no matter what the business of your business is, we know that delivering software quickly, reliably, and safely is at the heart of your technology transformation and at the heart of your organizational performance. We know this because it maps to our lived experiences. Each and every one of us have lived this. We know that delivering software is important. But we also know this because we have research that backs this up. So DORA, or the DevOps Research and Assessment Organization, is the largest and longest running research project of its kind. It provides an independent and tool agnostic view into the practices and capabilities that drive IT performance. Rigorous statistical methods are used to present data-driven insights about the most effective and efficient ways to deliver technology. But how do we measure software delivery performance? Well, in our research, we've found a valid and reliable way to do this. 2 metrics representing speed and 2 metrics representing stability. Because simply being fast isn't good enough. We have to be fast and stable so that our customers can rely on us. They understand the value that we're going to give them, and they trust that we'll be able to give them that value repeatedly over time. So I want to talk about these 4 key metrics for just a minute. I'm going to describe what they are. The first one is deployment frequency. This is really asking the question of how frequently are you pushing changes into your production environment? What's the frequency with which new changes are available to your customers? The next is our lead time for changes. Now, when we think about the lead time for changes from a measuring DevOps perspective, we really have to ask, when does the timer start and when does it stop? And so for our metrics, we say that the lead time begins, or the timer starts, when your code is committed to the version control system. So once you've done that commit into the version control system, the timer starts. And that timer stops when that code makes it all the way through to production, where your end users can use it. Now, of course, there are many steps that happen throughout that process. One could also argue that there are many steps that happen before you even get there. You have to decide, which features are you going to build? Which changes are you going to make? How will you architect those changes? How are you going to engineer those? We don't include those in our measurement because that time is highly variable. But what we do know is once you've committed to a change, and committed by committing a change into the version control system, the time that it takes to get to production should be relatively the same for any type of change that you have. So that's why we start our timer there. So those are our two speed metrics: deployment frequency, how frequently are you pushing things out, and your lead time for changes, from code commit to end users can use it. But of course, just moving fast isn't enough. We also need stability. And so when we talk about stability, the final two metrics come in. The first is the change fail rate. The change fail rate is a measurement of when you push changes to production, how frequently do you have to roll those changes back or otherwise get a human involved because some of those changes broke something. Now, if you think about this, we want none of our changes to break production. We don't want any of them to have any negative impact on our users. So how do we achieve that? We achieve that by testing those changes as they move closer and closer to production. But we also know that changes are likely from time to time to cause an interruption or to cause an incident. So we want to measure that. The next and final of our four is the time to restore service. So when we do have an incident or an outage that impacts users, how long does it take our team to recover? We know that it doesn't matter how we engineer our systems. We can be the best engineers in the world, engineer the most perfect systems. Those systems are still going to break. We know that we cannot get to 100% reliability. So we really want to look at, how do our teams respond and how quickly can we restore service when there is an incident or an outage. So with the research program, we use cluster analysis to allow teams to benchmark against the industry. You can identify your own team's performance as low, medium, high, or as elite performers. And when we look at the differences between those low performers on the one side and the elite performers all the way at the top, the numbers are staggering. The data is significant. You see that elite performers are doing 200 times more frequent code deploys. They're recovering from incidents and outages 2,600 times faster. Now, this data always just blows my mind, the differences between the two. And you know, when we think about this traditionally, I think traditionally we've looked at these things, these achievements, speed and stability, as trade-offs. But in fact, they reinforce each other. But you know, that's not really intuitive. It does seem intuitive at first that if you go faster, you're going to decrease quality. But the data show us that as velocity increases, so too does reliability. Elite teams are scoring high on both of these metrics. Well, how can that be? One way that we can think about this, we measure velocity in terms of that interval from when code is committed to when it's deployed to prod. One of the key ways that this is accomplished is through a technique learned from lean manufacturing: small batches. We want little increments of code continuously moving through the pipeline. These are my happy little bits of code, if you were wondering. Moving through the pipeline, the smaller the change delta, the easier it is to understand those implications. And so think about this: when I push a small change, if it causes an incident, it was a small change. I know exactly where that challenge was, and I can quickly roll that back. Uh-oh. Sorry. So I can quickly roll that back. It's also, this provides an underlying mechanism driving both of these. If you do small changes, you can deploy them faster. If you do small changes, the time from commit to deploy can be shorter. Your time to recover can be much faster, and you're less likely to cause a real incident or outage. So this brings us, or we call these the 4 key metrics. And I want to dig in it just a little bit deeper about how you can use these 4 key metrics to accelerate your own DevOps journey. And for that, I'm going to move from the slides here for a minute. I want to go and demonstrate something that we have made available to you so that your team can assess your own performance against these metrics. So give me 1 second while I just switch tabs here. Sorry. There we go. Okay, so I've now gone out to cloud.google.com/DevOps. You can see that browser still? Can you see that, Dina? Yeah, great. So from here, we can actually, with your team, you can take a quick check. This quick check will help you quickly assess how is your team's performance against those 4 key metrics. And we recommend that teams do this from time to time to get real insights into their team's performance. So I'm just going to go through the 4 questions, or as it turns out, we're going to ask 5 questions, but bear with me here for a second. So the first is lead time. So let's imagine, that we are working in an agile methodology, and maybe we have 2-week sprints. And at the end of every 2 weeks, we're deploying code to production. So our lead time in that case, our average lead time is going to be somewhere between 1 week to 1 month, right? Some of those things at the end of the 2 weeks get deployed pretty quickly, but some at the beginning have to wait 2 weeks before they're deployed. Our deployment frequency, again, let's say that's between once per week and once per month. Our standard cadence is we deploy about once every 2 weeks. Our time to restore service, how quickly does your team recover when there is an incident or an outage? We want it to be less than an hour, but occasionally it takes us a little bit longer. So I'm just going to say less than a day. And then your change fail percentage. So again, this is when you do push changes to production, how often do you have to immediately roll them back or get a human involved? I'm going to say that it's not quite as good as we'd like it to be. It's at 16 to 30% of the time. And then the last question that's really important here is your industry. So we want to help you compare with your peers in the same industry. So let's say that I'm in the financial services industry. Now that I've answered these 5 questions, I can actually view the results and see that I am a medium performer. And we can see information about medium performers here. What do medium performers do? They're deploying, on a regular cadence, but not necessarily super frequently. So for example, between once per week and once per month, just like we said before. So I can compare this. I can also do a performance comparison where I can look at how is my performance, or more importantly, my team's performance relative to the industry. So I can see the deltas. So this is this diamond shape here. This is all of the survey participants, and this is where my team is. So I have a little bit of room for improvement across a number of these. I can also then compare with my industry. And if you look closely, you'll see those diamonds move just a little bit when compared to the financial services industry. So this is how we start to measure DevOps. We can go to our teams and ask these questions. How are your teams performing? One of the other things that's really important here is improvement areas. So the way that this research program works, it asks you to help set a baseline, but then it thinks about, well, how do you get better at these things? And there's actually a whole body of research that tells us how to get better. Which capabilities do we need to improve our performance against those 4 key metrics? And you can see here that the tool has recommended continuous integration, continuous delivery, and architecture. Now, if we had more time, We could also then prioritize those 3 capabilities by answering some more questions. So with the DORA program, we start with survey data by asking our teams a number of different questions. But there are other options that we have available to us. And that's where I'm going to turn things back over to Dina here in just one second. And Dina's going to talk to us about how to collect those 4 key metrics. Oh, and that is not the right version that you want to see. Let's get this out of here. Let's get that there. And Dina. All right, Dina, over to you.
Okay, so I'm going to talk about an open source project that we have called the 4 key metrics, where we measure the software delivery and operational performance. Nathan just went through these 4 metrics: deployment frequency, lead time for change, change fail rate, and time to restore service. One really, I think, important thing to call out here is that these metrics are not correlated with business success. They are predictive of business success. So if you do well in these 4 metrics, that means that your business is going to do well. And we just went over what the survey looks like, which essentially just asks you like how frequently and what is your lead time, et cetera, et cetera. It goes in and directly asks what your metrics are, which when we're talking about, statistical analysis over thousands of respondents, over years, over, many different, different kinds of businesses and different kinds of people answering this, then you can really do some good analysis on that data. But when you're talking about just you and your team, it's very subject to bias, and you're just going by your gut feeling. And maybe you just had like this really big outage recently, so you have this feeling that you have very frequent outages because it seems like they're happening all the time. And so what we want to do is we want to go from this survey data to the systems data. And the good news is that you already have the data. Every time you write a little bit of code and you commit it and you push it to GitHub, GitLab, whatever you use, that's in a database. That data is there. You have your timestamp, you have the code, it's all there. Every time you make a deployment, you have the data. So we need to collect that data and transform it so that we can turn it into these 4 key metrics. So when we were designing this open source project, we started thinking about like, what does this look like? The main challenge is that developers use so many different kinds of tools and environments to do their work. So how do we capture all of it? If one team is using, I don't know, Tecton or some kind of Terraform, or somebody else is using Cloud Build, somebody's using GitLab, somebody's using GitHub, somebody's using Bitbucket, somebody's using tools that I've never even heard of. How does our team develop an open source tool that allows people using all different kinds of tools and environments to gather that data? And the solution that we came up with was to create this open source generalized ETL pipeline that takes in events via webhooks and ingests them into BigQuery. So in this model, the sources that we know we have mappings for them, so we can parse them properly. We can say this event that's coming in from Cloud Build, this is a deployment, so we're sending this and we're marking this as a deployment. And any unknown sources can be categorized by the developer with the edit of the SQL script, because everything goes onto BigQuery, and then from there we do the bulk of the ETL is in BigQuery, so that when we need to change things, and people will need to change things because your business logic is going to be different than mine, and as a result, you can just edit that in the SQL script. So we're going to talk a little bit about the data mapping, which is it's kind of like it's the meat of the project here. So we have this one table, this raw events table, which is in essence a DevOps log. It should contain every single event related to development, deployment, and incident management. So when in doubt, you stream it into the table. It's better to have too much data than too little. And so from the raw events table, we then create these 3 derived downstream dimensional tables, which are changes, deployments, and incidents. And with these 3 entities, change, deploy, incident, we can create our 4 key metrics. So we'll talk about the first metric here. We'll dive a little bit more deeply into it. It's deployment frequency, which is defined as how often an organization successfully releases to production. And the some key words there are often and also successfully. So we're not going to count in production. So we're not going to count like cases where you tried to do a deploy and it didn't compile, so it didn't deploy. What we're trying to get at is when and if the deployment reached the customer. So if it didn't successfully deploy, we don't care about it. It's probably the easiest of the metrics to collect and calculate because it just requires one table, which is deployments. And if you're using like a CI/CD system like Cloud Build or GitLab CI or whatever it is that you happen to be using, you have all the data you need. So we stream this information into our table and we use it to calculate frequency. And I will call it very quickly that there is a difference between volume and frequency. A lot of times when people start to approach this problem, what they do instinctively is this thing that you see in the middle of the chart that you see in the middle, which is a daily volume, or maybe they'll do like a weekly volume, etc. The research that the DORA team did, they found that frequency was really the metric that mattered. So it doesn't matter if you have these like 17 deployments today. If you're deploying daily, you're deploying daily. If it's 1 or 17 or whatever, and we're not looking at like the average daily deployment. So you can't offset your month by doing like 30 deployments in one day. It has to be at least one a day if you want it to be a daily deployment frequency. So the DORA team buckets each of these metrics, as Nathan showed you, into elite, high, medium, low performing teams. And in this case, the daily deployment frequency falls into the high performing threshold. And so in the dashboard from the 4 Keys project, we represent this with a green badge. Next, we have lead time to change, which is defined as the amount of time it takes a commit to get into production. So this requires 2 important pieces of data: when the commit happened and when the deployment happened. And this means that for every deployment, we need to maintain a list of all of the changes in that deployment. And so this is really easily done if you're using some kind of like trigger system that has the SHA mapping back to the commits. And so with these lists of changes in the deployment table, we can join back to the changes table to get the timestamps and then calculate the median lead time. And the dashboard puts the lead time into the buckets defined by the DORA research: less than a day, less than a week, a month, a year, less than a week is medium. So we're showing it with a yellow badge here. Next, we have the change fail rate, which is the percentage of deployments causing a failure in production. So to measure the change fail rate, we need to know 2 things: how many deployments were attempted and how many resulted in failures in production. The deployments, like the overall number of successful deployments, that is our denominator, and the failures is our numerator. So to get this number, we need our total count of deployments from our deployments table, and we need to link it to incidents. Now that can get a little bit tricky. You maybe are auto detecting some amount of incidents in, you know, an error detecting system. You maybe people like file bugs, or they put like labels on, you know, GitHub incidents, or maybe you just have like a form that's like, you know, this deployment caused an incident. Or ideally, you'd have, you know, a fully fledged issue management system. But the requirement for the 4Keys project is that the incident contains the ID of the deployment so that we can join these two tables together. And lastly, we have time to restore, which is how long it takes an organization to recover from a failure in production. And to measure the time to restore, we need to know when the incident was created and when it was resolved. The time it was created would be the time of the deployment, which included the failure, and the resolution is the deployment that fixes it. So similar to the last metric, you can get this data from, you know, a myriad of sources wherever your incidents happen to be coming from. We just need to be able to link these back together, the incidents and deployments. So little reminder, this is what the pipeline looks like. You know, you have the work that you're doing in the different environments. They send an event to a webhook, which then pushes all of those messages into PubSub. And those are each parsed by a different worker that is written just to specifically, you know, do the data mapping for that kind of event. So, you know, like the GitHub events go to this GitHub PubSub topic, and the worker knows what a GitHub event looks like. So it pulls out the data that we need to calculate the metrics, and it puts it into our raw events table. And from there, we have scheduled SQL queries that create our changes, our deployments, and our incidents, and that powers our dashboard, which looks like this. So by funneling all of our DevOps logs into BigQuery, we're able to categorize and calculate the metrics using SQL and visualize it in this dashboard. And the dashboard is designed to give us our high-level categorizations based on the DORA research for the 4 key metrics, but also to show us a running log of the recent performance. So down the center there, where we have the, you know, those badges, those are the 4 key metrics as defined, as backed up by 6 years of research. But on around the sides, we have, you know, our systems data that's kind of like showing us like daily how our performance is going. And one of the nice things about that is it allows dev teams to get an early sense of like the direction that you're trending in. So, you know, maybe you have some kind of experiment where you're, you know, adopting some kind of new practice or some kind of new software, and you want to see whether or not these lines start to go up or down. And you'll see that a lot longer before the badges flip over, because those are looking at, you know, a longer time span and in their buckets. So this lets you know whether or not you're moving in the right direction or perhaps in the wrong direction, and then you can, you know, change your behavior to mitigate that and start pushing it in the correct direction.
Nice. Thanks for that, Dina. And I know you love data. And so I wanted to have, I'd like to spend the next, I don't know, 10 minutes or so having this discussion of the pros and cons of using the system metrics that we can pull directly from the systems versus the survey data, like what I showed at the beginning. So what do you think? What are some of the advantages of pulling that data directly from the system?
Well, I think some of the big advantages is that it helps remove bias from the equation. So everything that anyone does, there's always bias, sure. And this is no different. And so, you know, I think one of the ones I mentioned at the beginning was essentially recency bias. Also, you know, related selection bias. So if you've had a really big failure that was really messy, and maybe there was like some PR around it, and you angry customers and stuff, you're going to have an inflated idea of like what your failure rate is. But similarly, if you're only aware of the failures, then again, like that's selection bias. Like you don't know about like the thousands of times when there was a deployment and there were no issues. So again, like you're going to have like a completely skewed idea of like what the development system actually looks like.
Yeah. And I think, using that survey data, you're totally right with the bias, right? You get the perception of how the system is performing. With the system metrics, you get the data behind that. And certainly, we're all humans in this system. So sometimes the perception weighs differently than the actual data does. Like you said, if we've had a recent big outage, like that may cause some that selection bias. Yeah. What about what are some of the dangers though of using the system metrics, do you think?
Well, I think once you have something, there's always a danger with operational metrics. I worked on a team that was, operational analytics, and the moment you give somebody a metric, people change their behavior. Like when you become aware of something, it's just human nature. Like even, like when you track your steps or you track your calories, you can try to like be as normal as possible. Even if like when you think about breathing, like the moment you start thinking about breathing, like it changes. So when you're talking about operational metrics, and especially if you're incentivizing it, if you're saying this is a good metric and this is a bad metric, then people are going to change their behavior. And, ultimately we want them to do that. But we want a metric to reflect reality. We don't want the metric to be gamed. And if it's over incentivized, and if like too much importance is put on it, like outside of like the actual like scope of the problem, then you get poor behaviors. So with these metrics, we're really like taking like a zoomed out view of your team over time. It is a large, zoomed out, almost like executive level like view of like what your team is doing. And the temptation to drill down and really focus on things that don't matter is so strong when people have the data.
Right. So you talked there about gaming the system. And when I think about the 4 keys and how do you game the system, let's say that we have a team that's responsible for developing the features and so forth, and we have a team that's responsible for running the production systems. Let's say that those are still 2 separate teams. If we all own or have responsibility for those 4 key metrics, both the speed and the stability, if we share those as incentives, how would I game the system? Like, boy, maybe if I see my change fail rate going up, maybe what I could do to game the system and to bring that back down is just deploy, right? And maybe I'm not deploying many changes at all. Maybe they're tiny changes. That feels like I'd be gaming the system. On the other hand, it feels like now I'm building a muscle to deploy, which maybe is a good thing in the end. So yeah, what do you think?
I think in that example, it is a good thing. Or if you just start like deploying even the same image every day, like and there aren't any changes in it, you're just trying to bring up your deployment frequency, then yeah, that is a good thing, because you've built the system that allows you to do that quickly and efficiently. That doesn't take like 10 people like 2 hours to do, and that is a good outcome. Where it wouldn't be a good outcome is if you change the definition of a deployment just to try to bring up your deployments. So it could be that you have like a staging environment, and you could start including your staging deployments into your deployment count to try to push up that number. But if the customers are not able to access that staging environment, then the point of these metrics is ultimately, it's like what are the customers experiencing? How quickly do we go from code to customer? Do customers experience failures? And then if they do experience failures, how quickly do we fix it? So like we're looking at the customers, and we're doing that because we care about the business. We don't care how quickly and how well you deploy to staging if your deployment to production is this gargantuan one that has like 27,000 changes in it.
Right, right. And those 27,000 changes, that I think that increases your likelihood of a failure also. But a failure in only one or two of those changes. So then how do you untangle that to roll it back properly and so forth? That can be a real challenge.
Exactly, exactly.
I think there's also, you mentioned like changing your definition of deploy. I think this also helps uncover some of the challenges with pulling the system metrics specifically around what does it mean for a change to be in production? And if I think about the way that we deploy changes here at Google, right? When we deploy a change, typically we're doing a progressive deploy where maybe we deploy that change to 1% of our users, and then to 5%, and then 10%, 100%, and so forth. So what do you think there?
I think that's like one of my favorite things to talk about. It's because, it comes down to business logic. And I'm not going to prescribe like this one definition of deployment, because it's not one size fits all. Every organization, even within Google, they do their business a little bit differently. And so essentially you have to be extremely clear. And that's another thing, like one of like the risks of using the systems data is not being clear about your definitions. So you need to like write out all of your assumptions of how the system works, because the system should reflect, our concept of reality. And if you're counting a deployment with 1% traffic, but that's not actually considered a deployment in your organization for some reason, then that shouldn't be counted. But that being said, we keep all of that data in the raw events log, because your definition of deployment may change over time. And that's another like nice thing about having this data, is that you can, if it changes, you can adjust it and you can project it back as well, so that you can see like under this new definition, have we improved?
Right. Great. So when it comes to system metrics versus survey data, can we agree that the question isn't, it's not an or, but maybe an and is what gets us to the best answer?
Yeah.
Doing them both, right? Understanding how our teams feel about it, and then exactly what the system shows. And I like the idea there that you mentioned of using the system metrics also as kind of an early warning system. We can see quickly that we're about to, either improve or that we're declining. One of the challenges, of course, with survey data is if you want to get more precise or more data through surveys, that means you have to do more surveys. And then as humans, we get survey fatigue and don't want to participate in those surveys anymore. So I think it's like with all things, right? It's a balance, and both have their places and both are very useful. But I think the most important thing to remember is coming back to those 4 metrics and thinking about how do we actually improve. So it doesn't really matter where my team is, if I'm a low performer, a medium, high, or elite performer. The key is that you have room to get better. And some of the research really digs into those capabilities that will help you improve as a team. But the thing is, it takes a lot, right? Changing culture, changing behavior, incentives, it's all hard, and it takes alignment at all levels. You talked about having an executive view. Of course, our executives have to be involved in this, but it's the practitioners, the people with hands on keyboards that are doing the work. But we have to have alignment across all of those levels within our organization, and then horizontally across all of the different departments. And so this alignment, it takes trial and error, and it takes time. But there's good news here. It doesn't have to happen all at once. We don't have to make all of these changes tomorrow. In fact, something Dora studied for the first time is like, we will probably fail if we try to change all at once. And this is something, again, that Dora studied and really looked into. How do teams succeed? And what they found was definitely that trying to boil the ocean, if you will, or trying to make a full change across the organization all at once, it simply doesn't work. So before we switch over to Q&A, which we should have a couple of minutes for, I want to leave you all with two resources. First, cloud.google.com/DevOps. At this URL, you can find that quick check that I demoed earlier in our talk, and you can find all of the research program behind Dora. And then Dina. Oh, sorry.
Whoops.
Here we go. That's for you.
There we go. Yes. Yeah. So you can go try out our open source project at github.com/Google Cloud Platform/4keys. It works with a variety of different sources, and I am very much enjoying the feedback that we've gotten already. So leave feedback, file issues, write pull requests. That would be great.
Awesome. And that leaves us about 3 minutes for questions. I see there is one question here. Dina, it was posed to you, so I'll read it out loud to you. What should be recommended practice for linking an incident to a specific deploy? How do you really connect those two together? What if the deploy that caused the incident was actually a previous deploy? How do you find that in the data?
Yeah, exactly. That's why I don't go, the 4keys project does not just go by like the most recent deployment timestamp, because those things are often not connected. And so what we did as an example, like an imperfect example, but an example in the project is if you put the SHA of the deployment in the GitHub incident, then it extracts that data from the event and then links them back together. It would be much better to have an incident management system where you can specifically call it like, this was the problem. But really, like, even if you just had like the simplest, like most bare bones thing that you need, it's just a list of your deployments and then a Boolean field of like incident, like true false, and default false. And when then there's an incident, you could flip that to true, because it's just a very simple rate count. The problem is linking that data together, and there aren't many good open source, easily accessible systems that help you do that currently.
One thing that you could do also, though, is as part of your sort of post-incident analysis, right? You don't need to know that this deploy was linked to this incident in the moment.
No.
Right? You can go back and flag that later. So as part of your sort of post-incident analysis or learning from that incident, you could then identify, oh, this was the most recent deploy, but it was this deploy 2 deploys back that actually introduced or let this bug escape. Let's flag that as the incident, right?
Yeah. And you could even, because our changes are linked to deployments, you could even link it to a specific change, like this line of code was bad, and then we can connect it from there.
Right. And we have time for one more question, which I'll take. So it's from Federico, and Federico asks, how do you correlate business performance if you're only measuring delivery? Where is the business value, experimentation, etc.? I think this is a really great question, Federico. And really what we set out to measure here is, how is our IT performance? Now, we've shown through the research that IT performance, specifically software delivery and operations performance, leads to better business performance, better organizational performance. But there is this question of like experimentation. How do we know that this is the right feature? Answering those questions is part of lean product management, I would argue, but is not necessarily part of the 4 keys and how we specifically measure DevOps. The point, though, is that when we get much better at shipping and shipping product or shipping change and making our systems stable, then we can do that more frequently. So that leads to more opportunities for us to run more experiments from the business side and really understand how do these changes actually tie back to the business value. So I think that by increasing our IT muscle, if you will, we get better at the business side of it as well. And the research does bear out that there is a true ROI in improving your software delivery and operations performance. So with that, I would like to say thank you so much for having us. Dina, thank you very much.
Yeah, this was great.
All right.
Okay, thank you. Thank you, Dina. Thank you, Nathan. It was great for us to have you here.
Excellent.
And maybe next time you can travel for the next Achilles conference in Latin America.
Yes, please, everyone stay safe and healthy so that we can be together in person next year. Yes.
Yes, okay. Okay.